Okay, good morning. Thank you for coming. So I'm glad to be here. I was here last year, and I'm glad to be back. So this time I'm presenting ADBA, Asynchronous Database Access API. This presentation has been put together by myself and our JDBC architect, Douglas Serber. Douglas cannot be here today, so I'm presenting. The Oracle usual disclaimer. I'll go through a quick intro and then walk you through the API using code. You know, it's gonna be a lot of code. So be prepared to see code, and the code will explain the API. Okay, so you will understand that, and then we will wrap up. Okay, so ADBA, this is a new Java standard proposal. So we are proposing this to become a Java standard because we believe that when the adoption goes through standard, you know, if you have it as a Java standard, people will adopt it. Okay, so this is developed by the Java JDBC expert group. We hope it's gonna make into a new future release. Okay, so why are we doing that? Well, because async has better throughput. Okay, but it's not just async, as we will see later. We're also addressing the reactive stream approach. Okay, so these are the goals. No user thread blocks. So the user thread submits something and returns immediately. You don't block. And then the implementation, or you can say the driver, will take care of completing the operation asynchronously. You know? So the user thread will return, and you can go do something else, and some other thread will take care of completing the operation. This is an alternative API. It's not a replacement for JDBC. Okay. And we target high throughput and reactive application. Entirely built on the Java SE library. There is no third-party library. Everything you will see here are based on Java standard mechanism, either in Java SE 8 or Java SE 9. Okay, but we can support third-party reactive stream database access API. For example, okay, why it's not there? Okay, later. I had a slide on R2DBC. Anybody has heard about this? Reactive, whatever database access by Pivotal, it's R2DBC. So R2DBC can work on top of ADBA. Anyway, so design choices, no reference to java.sql. Java.sql, that's JDBC. So rigorous use of types, what does it mean? It means if you look at JDBC, JDBC statement.execute takes a string. Okay. Now you look at prepare statement in JDBC, which is an extension of statement. You cannot have prepare statement dot execute with a string. It will throw an exception. So it's not a rigorous use of types. That's what we mean. Builder pattern, I think everybody's familiar with that. Fluent API, everybody's familiar with that. Objects are immutable after initialization. No reuse, no changing. One way to do something is good enough. We don't try to come up with different ways to do the same thing. No SQL processing by the driver. We will see one slide where you can see that different database vendors have different markers, parameter markers, etc. So the driver will not deal with those things. We just push the SQL statement as is from the user code. Avoid callback hell. I mean, people familiar with JavaScript have heard about this. They have workaround, but this API has been designed to avoid this phenomenon. Okay, so what about streams, reactive streams? Well, so ADBA uses Java util concurrent flow where appropriate. It's not 100% full-fledged reactive stream API. If you're looking for that, you need to look at R2DBC, which is on the next slide. So what is R2DBC? It is a reactive relational database connectivity. This is something proposed by Pivotal. It's on GitHub. You can see the links there on GitHub. So this adheres to the reactive manifesto. It's non-blocking back pressure. Okay, dependency on the reactive library. So remember what I said, ADBA has no dependency on third-party library, whereas this has a dependency on reactor library, which is a different reactive library from the one you will get from LintBend, for example, LightBend. So that's a problem. Anyway, R2DBC has a wrapper on ADBA, so they can use ADBA under the cover, okay? And we can work with them to make sure that they can use ADBA if they want to. Okay, now I'm gonna go through code to explain what is the API, and this is the most interesting part of the presentation. Okay, this is a very trivial insert. So we have an insert method. It has an argument. In argument, it has a session and an item. An item is sort of a POJO. So session is sort of connection, but it's not a real database connection. It's just a session. There is no socket establishment to the database. It's a session for now. Okay, so we have a session. Then we have a row count operation. In ADBA, there is no statement, prepare statement, callable statement like JDBC. No. There are row count operation if the operation returns a count, or there are row operation if the operation returns a rows, series of rows. So you will see row operation, row count operation, row publisher operation, etc., etc. So these are based on the return of the operation. So here in this example, we have an insert statement, insert into a table with 3 columns, 3 different attributes. And those attributes, we will use them to build the item, which is the POJO. So we will set the item with the ID, with the name, with the answer, and then we submit. So that's all the user thread has to do. Prepare the operation, submit, and return. ADBA is heavily based on completion stage. Okay, this is a very large interface, and the implementation is a completable feature. So it's a very big, and I cannot cover it here. If you want more details, you can look at this, but this is a standard Java mechanism to do event-based mechanism, event-based programming. It supports lambda expression, fluent programming, composition of tasks, etc. So this is a very good tool for ADBA. Execution model. Everything in ADBA is an operation. An operation is everything which deals with the database. So it could be a SQL or some other operation that attached to the database. That's an operation. Okay, results handling, submission, completion stage, etc., etc. So user thread creates and submits operations. That's it. You submit the operation and you return. Okay, the implementation now executes those operations asynchronously. So you disconnect, the submission from the execution. Another example, get data source. Okay, get data source, it is already provided by the API, So what you need to do is get data source, which is a function. We're gonna get a new factory. In this case, the factory will get the data source for the Oracle database, but you can imagine same thing for Postgres, MySQL, etc. Okay, so we get the builder, we get the URL, we set the value for the URL, for the username, for the password, and then we build the data source. Okay. But you don't have to use, we have convenient method that you can use. For example, get session. This is the implementation of get session. Take a builder, build, and then attach. So attach translates into, and I'm showing you the code of ADBA. This is the code of the implementation. So it translates into submit an operation group. I will explain later what is an operation group. Then attach operation and submit. Attach operation attaches the session to the data source. So when you get a session, that's what happens under the cover, and you return. Okay, another example, IDs for answer with data source as a parameter, and it will return a list of integer, which is the result. Okay, so we have a try with resource block here, try with resource block. So we get a session, and then on the session, we invoke a row operation. So a row operation is an operation which returns rows. Okay, so the row operation will execute the select statement, select ID, name, answer from a table where answer equal a value. So we will set a value for answer, which is the bind variable. And you can see that every time we specify the type of the parameter. Okay, so how do you process results? You collect them, right? So here we're gonna use the collect method. This is a convenience method provided by the implementation, but under the cover, it translates into the collector, you know, the usual Java collector. So here we give him a supplier, and then we give him the accumulator and an accumulation function. So what's happening here, we're gonna build a list, we're gonna build a list with an integer which is at the column ID. Okay, so you stuff the IDs into the list, and so we prepare everything, we submit. When the implementation executes the operation, that's what's gonna happen under the cover, asynchronously. It's gonna execute the SQL statement and stuff the result into the list and return a list of integers. So one thing I need to mention here is the type witness. We use this a lot. This is important. But if you're using a framework, the framework will generate the code for you. We don't think that people should be coding ADBA API directly. I mean, skilled people will do it, but we think if framework should be doing that. This is the close operation. So a close operation is never skipped. And a close operation, as you can see, it calls close operation and then submit. So it never blocks. Nothing blocks. You know, the whole API is built in a way that no operation blocks. Nothing. Everything returns immediately to the user code. SQL. So all SQL are vendor specific. We do not try to come up with an abstract SQL like in JDBC. We don't deal with parameter markers. We don't deal with all sort of things because they add overhead to the implementation and increase complexity. Okay, so for example, at the bottom of the slide, you can see the different parameter markers used by different database vendors. You know, like DB2 use column, MySQL question mark, Oracle database, same as DB2, Postgres, etc., etc. So we don't want to deal with those things at the API level, at the implementation level. So we just push down the SQL as received from the user code. Of course, if you are using a specific database, the implementation of ADBA will deal with that specific parameter marker. For example, if you are using ADBA with Oracle, we're gonna deal with the Oracle parameter markers. We're not gonna try to deal with all sort of parameter markers. Okay, so this is a little bit more complex query operation. So here we have a public method named items for answer, which will return a completion stage, which is a list of items. So item is a POJO. Okay, so we have a data source as a parameter, and we have an answer as integer. Okay, so try with resource block, get a session. Okay, and we're gonna return a list of items, and we're gonna perform a row operation. The row operation will process the select, ID, name, answer from tab, etc. You know, as the same example we used previously. And we see we set the value for the parameter target. And then we have a collector, and we're gonna collect. So this is the convenience method, which uses the Java collectors, and we are mapping. So this is a mapping function, which means we're gonna apply for each row. We're gonna build a new item by getting the ID, the name, and the answer from the row. From the row, we recoup the different values, and then we build the item. Okay, once we build the item, we stuff this into a list. We invoke another collector to produce a list of items. So that's what will be returned. So the user code specify all those, the submit, and then get a completion stage. Okay, so submit returns two things: a cancel and get completion stage. So this is how we can get a completion stage when the operation is available. Everybody is here familiar with completion stage, completable future, right? It's a software box which will carry the result when the execution has happened. And then it will trigger the execution of other completion stage which are attached to it. Okay. Transaction. This is more complicated. Transaction. Okay, so transaction, we have a transaction and then a data source. Try with resource block, get a session. If we cannot get a session, if get a session does not complete successfully, we're gonna return an error. Okay, assume everything goes well. So here's a problem. Remember this API, you submit and you return. The execution happens later in the future. So how would you make the determination of the outcome of a transaction? You don't know what's going to happen to a transaction. And by the way, in this transaction, we will have two operations. We will have a select operation, and we will have an update operation in the next slide. Okay, so it is a transaction made of two operations, but we don't know what's going to be the end result. And we cannot anticipate, and you cannot code to it because you don't know what's going to happen during the execution. So we have to make a provision for a mechanism that we're calling transaction completion. So that's what the trans is. Trans here is a transaction completion mechanism. Sorry, I don't know what this is. Okay, so this is a transaction completion, and it's a flag. And we're going to set the flag depending on the outcome of the different execution of different operations that made up the transaction. So here, so the first thing we have completion stage, an integer. ID promise is a completion stage. It's an integer, but it's a completion stage, which means its value will be set in the future. Okay, so we get a session, we do a row operation, which is a select statement. Select ename from employee, where ename equal a parameter for update. Select for update. Okay, we set the value for the bind variable, and then we're gonna collect. So in this collector, we invoke a collector, so collecting, and then it's gonna do the mapping. Okay, so we do the map, create the list, and then get the first value of the list. So we're gonna just get the first integer of the row sequence. Okay, so that's what all this collect stuff does. Okay, so on error, set the flag to rollback only. If this operation is not successful, we're gonna set the flag. The transaction completion, we're gonna set the flag to rollback. Okay, and then we submit, we get a completion stage, and we move on to the next operation, which here is a row count operation. Row count operation because update returns a count. Okay, so we have an update, We set the value for the bind variables. We set the value 50 for the first one. And the second one, the value of the second bind variable is ID promise, which is a completion stage, which means the value will be set when the previous operation completes. Okay? I think that that's easy to understand. So if the count, we apply get count, if the count is different from 1, then there is a problem. So we say wrong number of rows. Otherwise, we just return the count. If there is an error during the execution of this, we set the transaction to roll back, the completion to roll back. And then we submit. So that's what the user thread does and submit. Here, this is the place where we cache the error of both execution, of both operations. Okay? So if any of those operations was not successful, we're gonna set rollback or commit, maybe rollback. Depending on the value of trans, it's gonna be either commit or rollback. This is how you're gonna work with transaction. Multiple operations happening in the future, you have no control. You cannot go back and change the outcome. Or, you cannot send a commit or rollback once you submit the operation. You have no control, no access. Okay, operation group. Operation group are set of operation. Wow, we only have 5 minutes. Okay, I need to rush. Okay, it's a group of operation, It's handled as a completion stage. So you have members, and members can be submitted, can be processed in sequence or in parallel, can be conditional, and we have an error handling as well. Okay, I don't have time to go through the operation, but please look at the slide and you can understand the different thing. But it's the same approach. You submit, you get a completion stage, etc., etc. Okay. Okay, this is where we support flow. We support reactive streams. We do support concurrent flow. For those not familiar, this is how it works. So you're gonna implement the subscriber interface, which means you will implement unsubscribe, on next, and on error, and on complete. Okay? So you request a number of rows, and the ADBA will give you the number of rows. So the idea is we give you what you can absorb, what you can process. So this is a non-technique, back pressure, non-blocking back pressure. Okay, so we will use this to support what we're calling a row publisher operation. So here you implement the interface. I'm going quickly because we don't have time. Anyway, we're using this Flow API to provide you a reactive stream support. So for processing rows. Same thing for controlling the submission rate. If you're submitting session, you submit your operation, you need to make sure the implementation can sustain the rate of submission. You have IoTs submitting things, you need to control that. So we give you something we're calling request hook. So you need to implement the subscriber interface, and look at here, request hook. This is how you tell the publisher that you can sustain or you cannot, so it's gonna slow down. Last, controlling session creation rate, same mechanism, you have to implement the subscriber interface, and et cetera, et cetera. Okay, I need to wrap up because we're short of time. So, we have the API is here. So you can go and look at the API. It's on the slide. I have published my slide. I sent them the slide, so you can download the slides. You can have an implementation of the API over JDBC and play with, so your code will compile and will run, but you will not have the asynchronous behavior because this is over JDBC. This is ADBA over JDBC. It's a functional implementation so that you can play with the code. But we really want everybody here to get on the discussion forum and see what people are saying about this API and contribute. because it's a community thing. If you don't contribute, you can say later, it was not, okay, I have 2 minutes, I can take one question. Anybody? We have 2 minutes. Yes?
How did you get your slide?
Oh, I sent to the event. They will post.
Oh, okay.
Yeah, I sent them the slides. So everything here is on the slide. No more question? No question? Okay, I hope you like it. Thank you for coming and enjoy the rest of the event.